In this session, we'll write a program for the learning to understand the learning in machine learning. So let's create a project, copy the previous project. We'll rename this as project 7. Brute force learning. Delete the binaries from the previous project and rename this as brute force dot c dot h. Open the project 7. Please rename it. Delete the previous files, add files. Okay. So go to this .c file. Now here, okay, let's go back to the presentation here. So now we need to update weight. Okay, we need to write an algorithm or an API that will update the weight until it reaches closer to the expected value, until the predicted value reaches closer to the expected value. Okay, insert. Okay, so now for this implementing this algorithm, what we need as an input is the input data, the weight, then the expected value. So predicted value we will calculate. So we need 3 inputs: the input data, weight, and expected value. With these 3 inputs, let us write the API void brute force learning neural network double input data. Second is weight, and third argument is expected value. Okay. Now we know that the predicted value will predicted value is equal to, and I'll copy the variable names so that I don't mistake spell mistakes. Input data multiplied by the weight associated with the data. So we'll declare this variable predicted value as double, type double, initialize it to 0. Now the error that we are going to calculate is or what we call it as delta. Delta is equal to predicted value minus expected value, right? Let us go back to the presentation. So here, sorry, that is the error. Delta is okay. This is delta, that's fine. So next step is error is equal to the square of this delta, POWF, in bracket delta comma 2. Save it. So this is the error, and we print the error in prediction here. Printf percentf error and predicted value. Print it here. Error percentf in prediction. Okay, now the next step is now so we'll calculate the new weight, right? Using this formula, so alpha is, in this case we have assumed some value. Okay, so this is basically a step. I would call this as, let us have this variable alpha defined here locally, double alpha is equal to some minor value, and what we are going to get is the new weight after this. Weight is equal to weight minus weight delta. Now what is weight delta? Weight delta is input into delta. Weight delta is equal to input into delta, and this is the new weight that we are going to get after this calculation at the end. Okay, so what we are doing here is so based on uh, the weight delta value that we get, we are adjusting the new weight value. Okay, now with this new weight value, we will run this loop again, and with the same alpha value. Okay, and we'll repeat uh, this operation, iterate for multiple times. But before that, we need to have we need to know whether which direction the weight is moving. Okay, whether it is moving in positive direction or negative direction. Now that is determined by the difference. Positive means like I would say it's not about positive or negative. Whether the weight is moving the predicted value closer to the expected value or not. Okay, so let us now call this function in the main. Delete all this part from the previous. and let us copy this the header file. The header file is name is different here. Brute force.h. Same thing here. Brute force.h. Okay, so we'll define few variables here as the input that we are going to pass to the brute force API. 0.5, the weight as 5, then input value again 0.5, and the expected value we will assume it as 0.8. That's it. These are the three inputs that we need to pass to this function brute force. Call this here the input weight expected value, input weight, and the expected value. Okay. Now call this in a loop because in the first iteration you're not going to get much learning because it is going to be for the single data. So when we call this, we're going to print it here. Prediction is error prediction value is this. Okay. Now weight, we need to pass it by reference because we are updating weight here. Weight, weight. Okay. So we are only updating the weight, not the input data. So weight we need to pass by reference here. Brute force.c here. So we are going to get the error in prediction is here, like this. And so let us compile and run this program. Delta undeclared. Weight delta we have declared. Alpha we need to declare, that is also declared. Error. Okay, so semicolon was missing. Run this code. Okay, the error is this 0.30, prediction is 0.25. So there is nothing, I mean, because this simple multiplication it did 5 multiplied by 5, which is 25. So let us now run this in a multiple loop for it. So iteration, we'll keep it as some big number. Iteration count and int I equal to 0 until I is less than iteration count. Iteration count we will initialize it to. For now, let us as it find it, then we will change it as needed. I plus plus. Okay, run this. 131. Let us increase the iteration. Okay. As you can see, as we are increasing the iterations, the prediction value is getting closer to the expected value here. Okay, so I'll increase the iterations to 50,000. Build it, run. Okay, as you can see, so error is almost zero and prediction is almost close to the expected value. Okay, this is how we can implement uh, this particular algorithm. And this method we are calling at brute force because there are the standard methods that are available. But with the understanding that we had the last session, the formula that we learned, we just try to implement on top of it programmatically how it can be done. And so this alpha plays a crucial role here. Okay, so every iteration, this alpha will be used either positive, like as an addition or subtraction, and to get the corrected weight. Okay. So this alpha will be operated on weight delta, and based on that, the weight will be adjusted. Thank you. See you in the next session.